day, everyone. I am Erickson Garo together with my fellow group members RJ Azores and Melody Solmeron. We will discuss or report to you our appreciation output of Chapter 1 and Chapter 2 of Mathematics in Modern World. Now, let's discuss what is mathematics. What is mathematics in nature? Mathematics is a broad field that deals with scientific data, measurement techniques, and direct observation, as well as inference, deduction, and proof. It also deals with mathematical models of natural phenomena, human behavior, and social systems. It also offers students the opportunity to investigate and learn about mathematical patterns that may be discovered in the natural world, like like tessellations as well as the Fibonacci sequence. The science of shape, amount, and organization is known as the logic of mathematics. We use math in everything we do and all around us. It serves as the foundation for all aspects of modern life, such as smartphones, computers, software, ancient and modern architecture, art, commerce, engineering, and even sports. Mathematics as a study of pattern. A pattern is an arrangement which help observers anticipate what they might see or what happens next. A pattern also shows that we may have come before. A pattern organizes information so that it becomes more useful. Mathematicians claim that study of patterns, including geometric patterns and structures in numbers, is what makes up mathematics. We begin to develop this crucial mathematical habit of mind from our very early days of life. It involves recognizing patterns and structures in the world around us. Now let's go to the different types of patterns. First is logical patterns. Logical patterns are usually to be observed. One kind of logic patterns deals the characteristics of various objects, while another deals with order. Understanding logical patterns gives us foundation in mathematical relationships that we may use to learn algebra, analyze data, and solve challenging and mathematical problems. Next is number patterns. Number patterns such as 2, 4, 6, 8, 10 are familiar to students since they are among the first patterns encountered in the school. In general, this pattern helps to understand and to establish um, a common connection between all numbers. Next is word patterns. Patterns can also be found in language like morphological rules on pluralizing nouns and or conjugating verbs for tense, as well as the metrical rules of the poetry. Word patterns, it is a group of words that have common feature or pattern in words. They have some combinations of letters in them with the similar sounds. Example of it is word, words, then sword, swords, toe and toes, tomato and tomatoes. Last is geometric patterns. A geometric pattern is a motif or a design that depicts abstract shapes like lines, polygons, and circles, and typically repeats like a wallpaper. Geometric patterns, we can relate the mapping concept learned in the classroom to circumstances where placed in place in direction are important. In the process in the process of problem solving and developing higher order cognitive abilities, spatial understanding is also thought excuse me to be crucial. Next is golden ratio. Golden ratio is the divine proportion, also known as the golden ratio. The golden mean or the golden section occurs between two numbers of their if their ratios are equal to the ratios of their sums to the bigger of the two values. The golden ratio or equivalent to 1.618, which is symbolized by the phi, is intimately related to the Fibonacci sequences. It is frequently seen in nature and is employed in many different industries. It is utilized in daily life, art, and architecture. Golden ratio reflecting objects are most aesthetically beautiful and have more aesthetic feel to them in terms of structure and the design. It is apparent in the way of the flowers and foliage are arranged in the spirals. The golden ratio, which is as an illustration, the values are 2 over 1 equals 2, 3 over 2 equals 1.5, 5 over 3 equals 1.667, 8 over 5 equals 1.6, and 13 over 8 equals 1.625. Leonardo Fibonacci. Italian number theorist Leonardo de Pisano Fibonacci lived from 1170 to 1240 or 1250. He popularized a wide range of mathematical ideas, including what is currently called the Arabic numbering system, square roots, number rearranging, and even math word problems or puzzles. Fibonacci sequence. The Fibonacci sequence was discovered by an Italian mathematician named Leonardo Fibonacci. He pointed out that he discovered the sequence by just analyzing the group of rabbits being bred and reproduced. Fibonacci traveled extensively in India and in the Middle East before discovering the Fibonacci sequence. He learned that the Indian culture had produced a numeral sequence system known as the Hindu-Arabic numeral system through conversations with other merchants and mathematicians. The sequence of integers, known as the Fibonacci numbers, begins with a 0, is followed by 1, another 1, and then a series of numbers that is increased slowly. Each number in the series is equal to the sum of the two numbers before it according to the rule governs it. Example of it is 1 plus 1 equals 2, 1 plus 2 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, so on and so forth. Now let's go to the chapter 2 presented by Solmeron and Azores.
Thank you so much, Mr. Garo Erickson. Now that we're done discussing the chapter 1, let us proceed to chapter 2, that is about mathematics, language, and symbols. Next page, please. So as you can see in the presentation, there is a question immediately. And that question is mathematics a universal language? So let us read this one. This definition of a language includes mathematics, Math is used as a written rather than a spoken method of communication, according to linguists who agree that it is a language. The language of math is universal. Every country in the world uses the same symbols and organizational structure to create equations. So, the answer here is yes. Mathematics is a universal language. Next page. Thank you. Mathematical language. Mathematical language is an academic language that includes vocabulary and language structures when thinking about, talking about, and writing about math. Mathematical language is characterized by abstraction, symbols, rules, nonlinearity, and complexity of language, arrangement, coding, and decoding information. So this mathematic language, it connects the first question, right? If mathematics is a universal language, and the answer is yes. So also it indicates here that um language structures is when talking about, thinking about, and writing about math. So why so my so mm, also why it's universal language is because we use math in our daily lives. Think about it. um we ask kung anong oras na, or bumibili tayo sa store, which consists price and time is number, right? That's why it's a universal language. So next slide, please. Mathematical expressions versus mathematical sentences. A mathematical expression is the mathematical analog of an English noun that is it is a correct arrangement of mathematical symbols used to represent a mathematical object of interest. It does not state a complete thought, and it does not make sense to us if an expression is true or false. Next page. Thank you. Take a look at the table below to visualize the difference between expression and sentence in mathematics. So look at the first example, in English example. You can see here a person, which is Jose, Juan, and Gwyneth. And in mathematics expression, it indicates here that 20.4 plus 3.3x fx fx equal to 6x negative 9. So you are not when we say expression, you're not sure if the sentence in example expression in mathematics is correct, or like like what I've said in like before, an expression we cannot make sense if it's true or false. So here in the second example, sentence with sentence in English, the province of Albay is a province in Bicol region, Philippines. And in a sentence in mathematics, 4 plus 9 is equal to 13, which is correct. 4 plus 9 is equal to 13, which is correct. We know that we are sure that it's true because in English sentence, it's true that the province of Albay is a province in Bicol region, Philippines. So here we have another example. Manila City is in National Capital Region of the Philippines, and in sentence in mathematics, 7 plus 5 is equals to 12, which is true. That 7 plus 5 is equal to 12, and sentence in English is also Correct. Fact that Manila City is in National Capital Region of the Philippines. So that's the difference of expression and sentence. If expression, we are not sure if the symbols or the symbol or the number are correct explanation. So in expression, we are not sure if it's true or false. But in sentence, it definitely and we are sure that it's true and correct. So this table visually demonstrates the difference between mathematical expression and mathematical sentence. So the next page will discuss by Mr. Azores. Thank you.
Thank you, Solmeron. So, our next topic is the characteristics of mathematical language. So, the language of mathematics makes it is easy to express the kinds of thoughts that mathematicians like to express. Uh, Example is precise, that able to make very fine distinctions. Second one is concise, able to say things briefly. The last one is powerful, able to express complex thoughts with relative ease. So the language of mathematics makes easy for us to comprehend, such as mathematical phrases and thoughts. It is precise and concise, powerful, because the mathematics requires us to give effort to learn. And moreover, this presentation will help you to practice to enhance your ability to comprehend, speak, and write mathematics and mathematical phrases. So next slide. So propositions. Example of first proposition is simple. So simple is proposition that are declarative sentence which do not contain a connective. So moving forward to proposition, it is defined to be sentence that is either true or false, but never both. So in propositional logic, each proposition, simple or complex, must be capable of being either true or false. So the second one is compound proposition. It is formed from simpler proposition using logical connectors or some combination of logical connectors. So the compound proposition contains several simple proposition connective by connectives, such as and, or, although, if, and only if. The simple components of a compound proposition are denoted by lowercase, like P, Q, R, S, small case, small letters. Next slide, please. So, types of compound proposition. The first one is conjunction. It is a compound proposition which consists of two propositions joined by the connective and, but, however, also. A proposition is either true or false. So let's start with conjunction. It consists of two proposition join the connective, and it can sometimes be but and however. And also example of it is Michael has very much money, however she's not all happy. So the second proposition, compound proposition, is disjunction. So it is a compound proposition which consists of two proposition joined by the connective, or denoted by lowercase p or q. So it consists of two propositions join the connective, or has two meanings, use the inclusive or which is legal or type, denoted always by p or q. So the third one is conditional. Conditional proposition is a compound proposition which consists of two propositions joined by the connective if then, denoted by P or Q. So the conditional is or implication is consists of two proposition joined by the connective if then. It is read as if or then or P implies to Q. Next slide please. So the fourth one is biconditional. Biconditional proposition which consists of two propositions joined by the connective phrase if and only if. So the example if it is two angles have the same measure if and only if they are congruent. So the biconditional or equivalence is consists of two propositions joined by the connective phrase of if and only if. The word equivalence is implies that the truth and the proposition of the same truth value. So the last one is negation. Negation, the meaning negation is the action or logical operation of negating or making negative. How to use negation in a sentence. Example, I do allow you to go there alone. Second one is I do not allow you to go there alone. So the negation changes the truth value. So negation is the action or legal operation of negating or making negative. Example of it in mathematical phrases is 4 is an odd number and 9 is an even number. That's all. Thank you.